Alright, who's still alive after chapters 1 and 2? Hopefully you're ready to be harder, better, faster, stronger at chapter 3. Now, chapter 3 is going to be a pretty new topic to most of you. You might have seen some of this in Algebra 2. I know that Miss Thompson and some of the other Algebra 2 teachers really covered linear regression and other types of regression like quadratic regressions. And really the whole main idea behind a regression line is that we can take data that we've gotten and try to predict other values that we didn't get. And sometimes a straight line will work great, sometimes a curve works better. For the most part, in this class, we are going to focus on a straight line regression. We might mention later with the portfolio assignment that there will be some different other kinds of regressions, some curved regressions like quadratic, quartic, cubic, exponential, power regressions, things that fit better to curved lines. But again, the main thing you guys will be tested on in Chapter 3 is just linear regression. So our first section we're going to look at is over a topic called scatterplots. And a scatterplot pretty much sounds like what you think it's going to be. It's a plot of data that can typically look scattered. Now, the purpose of a scatterplot is to display the relationship between two quantitative variables. Remember, quantitative means that these variables must have numerical values to them that would make sense to do mathematical operations on, like finding the average of. Okay, so there can be no categorical variables. Not even one of them can be categorical. We will talk about later in some of our scatterplots how you can display some categorical data in your scatterplot, and we'll talk about when that would be appropriate and why you might want to do that. Some requirements for a scatterplot. Number one, we're going to have two different types of variables. We're going to have an explanatory and a response variable. Now, explanatory variable is going to kind of be like your independent variable, the information that goes on your x-axis or your horizontal axis. So you're always going to put the explanatory variable, what you're trying to use to explain if there's a relationship with some other variable. And that other variable is the response variable that's receiving the explanatory variable. And it's always going to go on the y-axis. Now, there might be some times where you don't really think one is particularly the explanatory variable and one's the response variable, that it could be very easily switched around. And sometimes there might be those cases. So if you don't know which one goes where, then you could just make it up to your own self. Typically things like time that you don't have control of or that has very finite control will typically be your explanatory variable. And things that happen as a result of time passing, which could be a whole variety of things, will be your response variable. And we'll look at two examples in the notes today. So the first scatterplot here, we've got percent of graduates taking the SAT from 0 to 100%, and the state average SAT math score from a minimum of 420 up to 640. Now in scatterplots, here's all your scattering of your points here, and all of these points represent various states. And notice some of them have special symbols here, and for example, this is West Virginia, here's South Carolina, Georgia, DC. And here's a key that if you want to differentiate some of your points, for example, the plus signs here mean specifically the southern states, and we labeled 4 of them here, while all the other states just have points, just little circles in there. And we'll focus on why we're wanting to focus on the southern states here in a bit. Now, just like in Chapter 1, when we talked about describing a distribution, we're still going to be doing something very similar with scatterplots. And we're going to be looking for a pattern. And there's three different things to the pattern you're going to be looking for. Number one, you're going to be looking for a pattern in direction. And by that, we mean a positive or negative association. Sometimes there may not be a positive or negative association. There may be no clear direction. Now, what I mean by that is, notice these points up here. It seems like as the percent of graduates taking the SAT increases, that the SAT scores decrease. So if you kind of think about back to Algebra 1, there's kind of, you could fit a line that kind of fits, well, if I could do this not in white, fit a line that goes about halfway between all those points in there, that this line would have a negative slope. And if all of our points were going uphill, then that would have a positive association. We're not going to use the term slope, but rather association. But it's the same idea as back in Algebra 1. Now, besides positive or negative association, increasing in x and increasing in y, or a decrease in y for an increase in x, we're also going to focus on form. Primarily, we're going to be looking for, this is what we're going to hope to find, is a linear form. And notice that all of our points, they don't directly line up and make a straight line, but for the most part, they're going all in the same direction as the percent of graduates taking the SAT increases. So this would be an example of a linear form. Now, we will see some curved forms, some clusters, different other kinds of forms. We'll run across them, we'll discuss. But curved and linear are probably the main two we're going to run across. And curved will be very obvious when they are curved. The third thing in your overall pattern, besides direction and form, is strength. And we're going to rate the strength of the scatterplot on a weak to strong scale. And if we can say that our scatterplot has a strong strength, then we can make pretty accurate predictions about other values. Like if we came along and said, well, if here's our 50 states, and let's include, let's say Puerto Rico into it. Let's put the 51st, quote unquote 51st state in here. Well, if we knew what percent of graduates were taking the SAT from Puerto Rico, we could use, and this will be something we'll talk about in a few days, but we could use this regression line to say, well, if 35% of graduates from Puerto Rico were taking the SAT, we can predict that we think their score is going to be about a 540. So that's what we're going to get into later, okay? But for now, we're not going to have this line in there. We're just going to focus on the points in general. Now, besides direction, form, and strength, we still need to look for outliers. And outliers, by definition, is any observation that falls outside the overall pattern of the graph. Now, for the most part, these points up here, let me get rid of some of these blank lines, most of these points are following an overall pattern, as you can see right here. Now, let's say there was some rogue state that was way up here, okay? A lot of their graduates take the SAT and they do very well. Like maybe this is some very smart, maybe a small state that most of their students are going to do very well because they're such a small state and they're just very brilliant students. This does not follow the normal pattern that we see here. So we would probably call this point an outlier. We're not going to have a rule like the 1.5 IQR rule for determining outliers. It's literally going to be, again, by looks. If it looks like it's out of the norm, then you can go ahead and call it an outlier. And we will discuss later what do we do with those supposed outliers. Because sometimes they have more influence on things we're going to talk about later, so I'll just kind of shut up about it. Now we're going to look for patterns, and here where we can look for patterns among our different categorical variables of interest. So remember I pointed out that some of these points are southern states, and we're going to make them a separate symbol. Okay, we're going to use a different plotting symbol to indicate categorical variables. So I take some of those points, some of those dots, and this is where I made the plus signs. So now if you only wanted to focus on southern states and look for a pattern within them, you could do that. If you wanted to make a different symbol to represent states in the Midwest or states on the east and west coasts, you could do that. I mean, you can see some of our southern states, we have very few, 0 to 20% of graduates taking the SAT, and they do reasonably well, in the 540 to 560 range. You got West Virginia that's kind of not following suit with all these other states. And then you got this other cluster of southern states where 60 to 80% of their graduates take the SAT, and they do, maybe around a 480 to 520 range. Now you could discuss and try to figure out, why do some southern states do better than others? And one thing I want you to notice is, look at how many more graduates in these southern states take the SAT. This means that not only are your smart kids taking the SAT, but really any college-bound student is probably taking the SAT. So this includes the people who aren't at the top of the class, but still would like to apply for colleges. So their scores get knocked down. Now notice this cluster over here to the left, you have very few people taking the SAT, but they score very well. These are the people that are probably going to be applying for, Ivy League schools, prestigious East Coast, West Coast schools that probably other students normally wouldn't apply for. So that's why these are probably your very smart students, and they're going to score very well because they're smart. So that's one thing you could do with a scatter plot. You could dive into it further and examine different aspects of some of your points. All right, so now we're going to actually define describing a scatter plot. And this statement right here, this is kind of like your SOX statement, but for scatter plots. Okay, you're going to make every statement look very similar to this. So we're going to say there is and first we're going to talk about strength. Really, you could talk about direction, form, strength. You could mix these up any way you want. Typically, we'll start off with strength, then talk about direction, and then form. But again, it could go in any way you want. Now, again, all of these points were lined up pretty well, so I would consider that a moderately strong strength in here. And it'll take a while for you to finally get used to, what's considered moderately strong, what's strong, what's very strong, what's fairly strong. There's going to be all sorts of adjectives you can use with strong. You could even just use the word strong. And there's different numbers that we'll talk about in the video tomorrow that kind of relate to the strength. We can tie a number to the strength, but that'll be for tomorrow. So for now, we're going to call this moderately strong. You could call it fairly strong, but it definitely is some level of strong. A weak strength would be points that are pretty scattered about. Maybe they kind of look like a circle. Maybe making an oval would be a fairly weak strength in there. And we'll look at some examples of those too. Now the direction was positive or negative, and it looked like this would have a negative slope to it. So there's a negative direction. And form, again, it looked pretty linear, that it looked like these points were generally following a straight line direction. So you're going to start out by saying there is a moderately strong negative linear relationship between, and now you have to describe the two quantitative variables that you're trying to find a relationship between. And that was our percent of graduates taking the SAT and the state average SAT math score. Now you might also comment on, this next part is optional only if you notice something else going on in the scatter plot, or if you want to comment on other things in your scatter plot. We could say there are also two clusters of scores, and the southern states are identified as plus signs within the scatter plot. So you could say, you know what, here's a cluster of states that are all kind of together, and here's a cluster of states that are all kind of together. If you notice those clusters, you probably want to comment on them. If there were more states, let's make up some extra states, why not? Let's say there were some extra states in here, and then you couldn't really distinguish two clear clusters. Then you just wouldn't say anything at all about there being clusters. But if it's very noticeable, you probably should comment on it. And if you want to, this part right here where we talked about the southern states identified as a different symbol within the scatter plot, you're not always going to do this. Very rarely are we going to do this in class, where we're going to take some of our data and classify it by something categorically. Okay, but if you decide to do it, you have to mention it in your description of the scatter plot. Now, it says the average SAT scores are often used to rank state or local school systems. Is this appropriate? Now, if you remember, we talked about there were two clusters of states here. We have these states and this cluster of states. Now, the main reason why, and I've already kind of alluded to this, of why there's kind of two clusters within the southern states, is typically in the Midwest, you guys take the ACT to apply for colleges. Maybe some of you took the SAT, but you probably only had to take the SAT if you're going to apply to an East or West Coast school, because they primarily want the SAT. So if we focused on, let's say, these schools here, these highest scoring schools, that they're not Southern schools, I know for a fact that that top one right there belongs to Iowa. Okay, and why do you think Iowa scores the best? Well, if you look to see how many people are really taking the SAT in Iowa, it's maybe 5% of students that are taking the SAT. And it's going to be those students who really want to go to Stanford, Yale, Harvard, those Ivy League schools that are applying to go there. Okay, so this is very few people, but they're scoring very well. These are the smartest kids probably in Iowa that want to get out of Iowa because they're tired of looking at corn and pigs all the while. Meanwhile, these states are probably more your East Coast, West Coast schools. Okay? They're the ones that, primarily on the East and West Coast, they take the SAT. They primarily don't take the ACT. So a lot of their students, notice between 50, about up to 80% of their graduates take the SAT. While in the Midwest, it's not very much. It's maybe between 5 and 30% on average. And they score more, or they score better, because those are your smarter kids again. But this is, most of your kids. The smart kids, the average ones, maybe the ones that are trying to sneak into a community college or something, and for some reason they require the SAT. I don't really know. But these are most of your students, and the not smartest students are bringing down the average. So it's not really fair to rank state or local school systems based on average SAT scores, because you have more kids taking it in these states than in these states. It makes these states look really, really good, and it makes these states look really, really bad. Okay, so again, it's not very appropriate because different states require the SAT in some of their colleges that are in those states, and some states require the ACT instead.